Okay, let's dive into this. We're about to pull back the curtain on a hidden blueprint, an idea from way back in the 1940s that's somehow powering the very device you're watching this on right now. It's kind of like the ghost in the machine, for every machine.
So let me just ask you this. Take a look at your phone, your laptop, whatever you're using. What could it possibly share with a clunky, room-sized computer that was built right after World War II? I mean, it sounds crazy, right?
Well, believe it or not, the answer is a single brilliant idea. A design so fundamental, so powerful, that it's been the bedrock of computing for like 80 years. It's called the von Neumann Architecture, and it is absolutely the hero of our story today.
So to really get this, we've got to start with the core concept. This one idea, this secret recipe from a genius named John von Neumann. It completely changed what a machine could even do.
And this is it. This is a big one. See, before this, changing a computer's job meant you had to physically get in there and rewire it. It was a nightmare. His proposal was, frankly, revolutionary. What if we store the instructions, the program, in the exact same memory as the data? And just like that, computers went from being clunky, single-task machines to these flexible, dynamic tools that we can reprogram on the fly.
So how does this actually work? Well, to make this super easy to get, let's just imagine your computer is like a really, really efficient restaurant kitchen. It's time to meet the crew.
Okay, here's our little cheat sheet. On the left, you've got the techie terms, and on the right, our kitchen analogy that makes it all make sense. We've got the memory, the control unit, the ALU, and the I/O system. Together, they're the dream team.
First up is the memory unit. Just think of this as a gigantic, perfectly organized pantry that also holds all your cookbooks. Every single ingredient, that's our data, and every single recipe, our instructions, has its own specific spot on a shelf, a unique address so it can be found instantly.
All right, running the whole show is the control unit, or the CU. This is our head chef. Now the chef and the kitchen appliances we'll meet next, they make up what you probably know as the CPU, the central processing unit. The chef doesn't do the cooking, but it's in charge of everything. It grabs a recipe from memory, reads it, and then tells everyone else in the kitchen exactly what to do and when. Now for the muscle, the arithmetic logic unit, or ALU. These are your high-tech kitchen appliances, the oven, the mixers, the knives. Anytime the head chef needs some actual work done, whether it's adding numbers or making a logical decision, it sends the ingredients over to the ALU to do the heavy lifting. Of course, a kitchen needs to communicate with the customers, right? That's the job of the input/output system. This is our waiter. The waiter takes your order, that's the input from your keyboard or mouse, and then brings you the finished dish, and that's the output you see on your screen. Simple as that.
And one last really crucial part, the registers. You can think of these as the little prep bowls right on the head chef's workstation. For any ingredients the chef is using right this second, they're kept in these super fast, easy-to-reach spots. It just means the chef doesn't have to run back to the big pantry every time, which makes the whole process way, way faster.
Okay, so we've met the whole crew. Now let's see how they all dance together. We're going to watch our digital kitchen handle a basic task, and it all boils down to this constant three-step rhythm. This right here, this is the heartbeat of the entire system. It's called the fetch, decode, execute cycle. First, fetch. The head chef goes to the memory pantry and grabs the next instruction. Step 2, decode. The chef reads the instruction to figure out what needs to happen. And finally, execute. The chef sends the task to the right appliance, usually the ALU, to get the job done. This simple loop just repeats over and over, billions of times every single second. So we've seen the blueprint, we've seen how the kitchen works, but the part that is just mind-blowing is how long this design has been around. I mean, this isn't just a history lesson. This idea from 1945 is still running our entire world. 1945. Just let that sink in for a second. This architecture was dreamed up before the transistor even existed, before microchips, way before the internet, and yet the core idea was so elegant, so powerful, that it scaled all the way from those room-sized giants to the supercomputer that you carry around in your pocket.
So what's the bottom line here? It all comes down to one game-changing idea: storing your instructions and your data in the same place. It's brought to life by that core team, our chef, our pantry, and our appliances, all working together in perfect harmony. And yeah, this brilliant 80-year-old blueprint is still the design for pretty much every digital device you own.
But for all its success, this old model isn't perfect. You see, having only one road for both instructions and data to travel on can create a kind of traffic jam, a bottleneck that slows things down. So that leads us to a final, pretty big question. After all these decades of running the show, is this brilliant blueprint finally starting to hold technology back? And what could possibly come next?